Yeah, thanks for all the help with the technical crew and Tejas, and thank you all for waiting. So back on track, let's talk about Concurrent React finally. You've seen this slide. This is me. The speaker deck for this session is available on this link and other sessions I do have. For a lot of the slides, you're going to see, okay, I feel like we could discuss this more and etc. So no worries, you'll find this emoji. That means we can talk after complex stuff. So just so that I know a little bit about you, so who's here is doing React 18? Oh, quite a few. Cool. Yeah, 20, 30. Cool. So I want to clarify that this session is a bit dive, and some parts of it are really towards people who are interested in API discussions and etc. So as a friendly reminder, you don't need to learn like half of it to be a really good React developer. So don't stress out at something are complex. So again, I want to hear from you. So if you had to summarize Concurrent React in one word or expression, what would you go with? For example, Tejas has a really good session on fibers, and if you watch it, you know, okay, fibers are like units of work React does internally. So if you had to do the same thing with Concurrent React, one word or expression, what would it be? 30 seconds, please scan the QR code and add your answers, because this is going to be really helpful in 10 slides from now. And I'll try to make small talk in the meantime, so that, because 40 seconds is actually a lot of time. But yeah, I'm going to allow some time. Scan, give your opinions, like what do you think is key about Concurrent React? One word, one expression. And another 9 seconds. And yeah, some of you are still scanning the QR code. So cool. Take your time, answer. Let's move forward. And actually, moving forward means taking one step back. So let's talk about the main thread of the browser. So for example, let's say we have this app and we have like buttons, we have some different kinds of inputs, we have anchor references and etc. And you can see that the moment I virtually block the main thread, everything stops responding. You've probably been in this place where you had to profile your app to figure out why this was happening. And if you've profiled your app to figure out why this was happening, you've probably seen those. So these red flags that we know as long tasks, you've probably fought them in the past. And these things are so real, even though that was a virtual example, but these things are so real that they're cause of behavior like this. So this is what's called rage clicking, and it happens basically when the user clicks a button, nothing happens, and then you keep clicking until something happens. And not only these are real, but we even have metrics, for example, first input delay or interaction to next paint and others to figure out how bad these are. And not only we have metrics, but we have tons of research on the topic as well. So for example, a couple of years ago, it was figured out that first input delay can be faced 7 times more on mobile. And there's a lot of other research. For example, long tasks, they also mess up with your TTI. And on mobile, you can have up to 12 times longer long tasks. And not to mention that on really old devices, a third of the loading time can be spent on processing long tasks. So that's really bad. And if you compare that with business metrics, that gets even worse, because you realize, for example, how it's impacting conversion rates and other business metrics. So, okay, we know that these are bad, and we know that we want to avoid them. So how can we do that? I guess that's the question. So let's imagine we have 4 things to run, A, B, C, and D. And we could, So we could start with parallelism, where we would have like different tasks running at the same time on different CPU cores. We could go with concurrency, where we have one single thread, but we quickly switch between the different tasks to give the user the idea of concurrency. And we have scheduling that's pretty much like concurrency, but here we have a piece of software called scheduler, assigning different priorities to different tasks based on some strategy, heuristics, or something. So let's actually start the opposite. So let's talk about parallelism. So when we talk about parallelism in the browser, I guess that the first thing of many of us think about is our web workers. So if you are not familiar with workers, basically data exchange happens via message passing. But this comes with two gotchas. The first thing is you don't have access to variables or even code from the page that created them and vice versa. And the second thing is you don't have direct access to the DOM. So if you want to make UI updates from within a worker, that's quite tricky. And the last thing is if we are working with workers, we end up usually with two abstractions, the actor model and the shared memory model. So the actor model, if you've done backend, especially in languages on the Beam virtual machine, you're probably familiar with that. So in this model, in this abstraction, each actor fully owns the data it is operating on and communication, and each actor can only send and receive messages. In this abstraction we're talking about, we can think as the main thread in the browser as the actor who fully owns the UI. And with workers, we do that with post message. But the thing is, post message is a kind of fire and forget mechanism. So you don't have a built-in understanding of request and response to track that. And the second thing is, okay, you're moving things to a worker because you want to optimize them. But at the same time, you might be introducing this communication overhead, and also you might have to handle, okay, what if that worker is busy handling something else? So you need to write that abstraction as well. The second thing, the shared memory model, it's based on the shared array buffer. So if you haven't checked it, check on MDN, it's amazing. And the amazing thing about it is that if you send it via post message, the other end is going to get a handle to the exact same chunk of memory. So that's great. But the thing is, we're talking about JavaScript, we're talking about browsers. So most of the APIs built around there, they were built with no idea of concurrent access to data. So because of that, you end up having to build your own data structures to handle that kind of thing, like mutexes or etc. And the last thing is kind of a convenience thing because you're not handling arrays or objects or things like this. You're doing just a series of bytes. So you don't have the regular comfort of JavaScript. And then there is WASM. WASM is also great, and in my opinion, it's like the best experience you can have for the shared memory model. But for a lot of developers, there's this learning thing where you don't have the comfort of JavaScript, so you end up learning something. And one tricky thing about WASM is that it's faster than JavaScript when you stay within the realm of WASM. But the more you have to cross that boundary to do, for example, UI work, you'll see that the less performant it gets. And actually, there's a lot of benchmarks out there showing, for example, how a lot of WASM frameworks, they are outperformed by things like Inferno, Preact, Svelte, Solid.js, etc. This is getting better and better through the years, but it's still a thing you need to consider. And before we move forward, I have to clarify that there is a lot of amazing work out there, open source software, and etc. For example, we have the Atomics data type. We have amazing libraries like Conlink and Workerdon that they make it really easy to do some of the things I mentioned to be problems. And there's Polytown that is like more recent, and you'll hear more about it. But so there's a lot of things, great things about workers. But overall, I still kind of have this impression that workers are great when you have to do some heavy processing or crunching numbers, that kind of stuff. But sometimes they're really hard to adjust for UI-related stuff. And sometimes I notice it's perhaps harder than using a scheduler, for example. So that's when we start talking about concurrency and scheduling. So back to the question I asked 8 minutes ago. Before we move forward, hopefully this is going to work. So those were your answers. And I can see that by far parallel was the most thing. And then we had threads and parallelism and etc. And it's great that we did talk about parallelism. But if I had to summarize concurrent React in one word, that would be the other way, scheduling. So for this, let's talk a little bit about scheduling in React. As part of this deep dive, I want for now focus on three different aspects: the heuristics behind this, the idea of priority levels, and one abstraction called rendered lanes. So we saw that there's no use of workers or parallelism in the end in React. So what we have, though, is this cooperative multitasking model where you have one single thread, but the rendering process can be interleaved with other actions happening in the main thread, including other React renders themselves. And that's why an update can happen in the background without giving the feeling of interruption, and then it can be resumed afterwards, for example, in response to new input or something. So it's easier if we can visualize. So let's say we have an original render task, like some table or something, and then some user starts typing. So we have user input, and that's high priority. So it's paused, and then it's processed, this high priority thing. And then, because of what we discussed, it can be resumed without problems. And if we check the source, we even find where it's happening. So we have this perform work until deadline thing that's basically going through the queue of things that React has to process and doing that one by one. But the tricky thing is, until React 17, this was done one by one and sequentially and in a blocking way. With React 18, you'll also find in the source of the scheduler this thing called should yield to host that is basically defining when React should yield execution back to the browser, should yield control back to the browser. And the heuristics it uses is that it yields execution back to the main thread every 5 milliseconds. And it's not a magic number. Actually, it happens because it's smaller than a single frame, even if you're talking about 120 FPS devices. So that's what makes that, in practice, rendering feels interoperable. And the other thing are priority levels. So we see them in the source of the scheduler again, and you see like different ranges of priority levels, and you see them throughout the whole code of React actually. So you find them in the reconciler, you find them within the renders like React Done, and even in React DevTools. And these priorities basically are different timeouts assigned to different things that basically will tell React when to run something. The last thing I'd like to explore with you is the idea of render lanes because they're brilliant. So basically, render lanes are abstractions built around bit masks. So one lane equals to one bit in a bit mask, and each updating React is assigned to one lane. So because of that, updates that are batched in the same lane, they are batched together, and in different lanes, then you have different batches. And in total, you have 31 levels of granularity, because that's how much you can fit in a bit mask. And the reason why they're great is because they give React a lot of control. So for example, it can choose whether to run things together or separately. And overall, it reduces a lot of browser overhead, like having multiple paints, multiple rate calculations, multiple flows, multiple layout classes, that kind of thing. And I don't know about you, but I myself, whenever I figure out those things from the source of React, that all sounds mind-blowing to me, and I'm always like this. But at the same time, every time I share them with a lot of people, I get this, okay, but we're not on Facebook, we're not car committing to React, so why does that all matter in the first place? So that's why I also like to bring the reflection of how we can benefit from the final results of these amazing concepts we have underneath. So that brings us to talk about scheduling for the rest of us regular front-end engineers. So for this, I gathered 4 different scenarios that you've probably seen at least one of them, but they're really handy. So the first thing is when we have to handle a lot of data in our apps. So it's crazy because we find a lot of non-practical examples out there on how to do that. For example, hey, I built this component and I'm going to run this cracking passwords algorithm, or I'm going to draw this fractal to prove how fast it is. And those are things that we're not doing a lot on a daily basis. Those are great for benchmarking, but it turns out that we can actually have really practical examples. For example, it is common for us to render a lot of things, many data points, or for example, render things on a canvas and we don't have off-screen canvas because of browser support, or even when we have to process data. So here's one example of a timeline where basically I'm filtering via the time span component here, records of visitors throughout different periods of time. And you can see that it is not terrible, but it's not great. The experience is not smooth, and it's actually you can tell the lags as I filter them, especially if I have a huge data set. The component doesn't have a lot of things. I have an effect where I'm loading initial data. I have some local state with use state, and then I have this dashboard component. And then I would like to change things to wrap that key part where I'm setting the data with the transition from React 18. So the final result is you can see that it's really smoother. And actually, no matter how big the selection I make, it's responsive to interaction all the time. And I myself, when I saw this kind of magic of transitions, I was really like, I wish I could go back in time. For example, about 6 years ago, I was working on this map application where I would have 100,000 data points plotted. And the users should be able to search and filter data and etc. And back at the time, we used web workers to parallelize some stuff. We used a lot of the Redux Saga utilities. If you know Redux Saga, that was great. And then we also used techniques like the bouncing and throttling and etc. But we could have used transitions and better scheduling primitives. And the second app was also a couple years ago. We had this admin panel for a real-time game where users would be texting, players would be texting each other, and etc. And as an admin, you should be able to search and filter messages and that kind of thing. At the time, we used a lot of virtualization and memorization everywhere to make it performance. But again, we could have used better scheduling primitives. And I guess that's one of the shifts we have to think about it when going from 16 or 17 to 18 is, of course, we still use MIMO things. We'll still optimize expensive components. We'll be still using techniques like virtualization, throttling, debouncing, etc. But we can also now think about of marking some UI updates as non-critical, non-urgent. The second thing is tackling wasted renders. So who here has seen this hook? It's called use sync external store. A little bit of raise your hands. Okay, few of you, like 10. Great. So this hook was initially sold as part of the Concurrent React features for library maintainers. And actually, back at the time, some state management libraries like Jotai or Redux even started using that underneath to be compatible with React 18. But again, how could we use that? So one thing I guess most of us know is React Router, and we're probably even using that. And let's grab one example. This is using React Router v5, but you can actually come up with a similar example in other libraries. So here we have the use location hook, and we have two different components. We're using the path name in one component and the hash in the other component. But this hook is what some people call an over-returning hook, because it's great, but it gives us a lot of information, perhaps some more than what we need. And here's an example where I have the two components, the path name and the hash one. And you can see that I'm using the React profiler here. You can see that the path name component is re-rendering, even though it shouldn't. Only the hash is changing, but both of them are using that same hook underneath. So how could we change that? Perhaps by leveraging the hook we just saw. So we're using usesync external store to build a new hook called use history selector. And inside our components, I now have a path name selector and a hash selector using the hook we just created. And the result is that now the only component which re-renders is the hash one, and path name is fine. You just saw a great session about hydration and SSR and etc. So I won't focus a lot here. But recapping what we just saw, this is what we used to have before. So we would have to fetch all the data in the server and then render the HTML, and that's when we got our first byte. And then we would load code on the client and get our FCP. And then finally, after hydrating things, we would have interaction. And that's bad because hydration could only begin after the data was fetched for the entire page. So not only users couldn't interact with the rest of the page until everything was done, but the bottom line here is that parts of the app that could be fast, they would have to wait for the slow ones. And then this changed with this new suspense SSR architecture in React 18, which is also part of the Concurrent React umbrella. And then we went from this to this, where because things are happening in different chunks, it's faster. So this is done using internally the new pipe to node string thing plus the create, hood, and suspense that you know. And React is clever enough to start to prioritize the hydration of the parts of the app that the users interact with before the others. And it's great because now components can become interactive faster by allowing the browser to do other work at the same time as hydration, thanks to the concurrent React thing. And the bottom line here is that now React doesn't wait for those huge components to start streaming for the rest of the page. And then, yeah, as we saw, when everything is ready, the HTML for the rest of the page is inserted in the right place via a script tag. So there's even case studies out there about the thing we just saw. So for example, Versal did one with the Next.js website, and they showed how they improved metrics like INP. And the last topic I wanted to discuss here related to that are the profiler enhancements, because not only we want to build faster apps, but we want to be able to properly debug them to figure out how faster they are. So under the scheduling tab of the profiler, you can inspect your transitions and a lot of different things, which is great. And my favorite part are actually the hints. So now you can, when inspecting things, React is going to tell, okay, this is actually heavy. Perhaps you can wrap that with a transition. And then that's really helpful because sometimes you don't see those improvement opportunities. A little bit about the future. So basically, there's so many things coming down the line. So we're going to have, for example, I/O libraries like React Fetch. We're going to have built-in cache for data fetching libraries to integrate with Suspense. We're going to have Suspense for CPU-bound trees, which is just amazing, because Suspense itself born as something towards I/O-bound operations. But we're going to, for example, be able to fall back some subtree of your app without even trying to render, because you know it's heavy to render that. We're going to have more hooks for library maintainers, for example, use insertions effect for style sheet libraries. There's going to be the off-screen component, which is also something great, because you're kind of rendering your component to an invisible DOM node, and that would be regularly blocking, but because of the concurrent umbrella of things, now you will be able to do that without any issues. There's several components, which we saw like a great talk by Tejas, and to be honest, I think we could even have a conference just about several components because it's a huge realm of things. And not only in React, but we're going to have, for example, native scheduling primitives for the browser. So who here has seen this prioritized task scheduling API? That's a huge name, right? So 2, 3 people, great. So it's not an API per se, it's an umbrella of different APIs that basically those are meant to be a more robust solution for scheduling tasks, something better than the primitives we have nowadays like set timeout, set immediate, or request animation frame. That's how we do scheduling nowadays. So this is going to be a way to control and schedule integrated directly into the event loop and promise-based. And it's result of a lot of teamwork and a lot of cooperation with React team, some teams at Google, the Web Consortium, and others. And this umbrella of API includes things like the post task, that is the main one, APIs for routing execution back to the browser, APIs for waiting for conditions, and things like isInput pending that you can use to check if the browser is busy processing some user input. And there's a lot of work around this umbrella of APIs around there right now. Facebook, for example, is the main one pushing the isInput pending thing. And now we also have open source on GitHub simulating this API. And Airbnb also has a great study case of using post-task scheduler. And another use case we actually have is if you check the source of React, of the scheduler more specifically, you will see that behind a feature flag, they are actually using the isInput pending feature already, part of this experimental thing of APIs. So a couple of closing notes before we go. So this session by Rich Harris is one of my favorite sessions in recent years. It's called Rethinking Reactivity. And he has this line where he says, React is not reactive. And he's right in the sense that it's not reactive, but it's concurrent. And that might be enough for most of us or most of our apps. That might be good enough. The second thing is another quote, this one by Guilherme Roche, the CEO of Versal, back when he was CEO of Zeit. He said that React was such a good idea that we would spend the rest of the day exploring its implications and applications. And I couldn't agree more, not only because we're here doing this, lots of people, but because we can see through APIs like this scheduler API that React is indeed pushing the web APIs to the future. And not even the web APIs only, but also other ecosystems, like native mobile ecosystems have got some inspiration from React. To make my next point, I'd like to check who here has seen this. It's called first-class support for promises. It was an RFC that was the hot thing in November last year, where basically, yes, a couple of hints. Basically, in this RFC, it was introduced a use hook that was basically a native way of doing promises in React, and everyone was talking about it back at the time. Reason why I'm showing this is this is about 40 lines of code. You don't have to rush to read everything. But basically here, we're implementing a hook called use promise. And you can see that I'm throwing promises here and there. And also, there's a small cache utility built. Why is that? If we check some code, we're using the use promise we just created in the component. And we're defining some delay, in this case, 3 seconds. And it's here. So we just recreated React.use from the RFC, and we did, of course, with a few limitations. But the point I want to make is actually understanding the internals and the rationales, the motivation behind those internals can be helpful for us to build our own abstractions and actually to be ahead of time building things that will be the future of React. And the first-class support for promises is just one example. The fourth thing is scheduling doesn't, by definition, mean that you will have always better performance. So, for example, you can have non-urgent updates taking longer, or, for example, there are some really expensive components within our apps that just doing proper scheduling won't fix them. Or we can even have extra GPU costs. Reason I'm saying all of that is the cliche that there's no silver bullet is true, and we need to always think about it. It's important that we identify the core metrics of our apps, especially because there is a lot of information out there. For example, if you've been following Twitter, you will see really smart people making really smart points, and it's easy to be confused amongst such a lot of information. So that's why I'm constantly reminding you, always correlate any performance work with your business metrics, with what's coming from your user, with real data, because that's what's going to matter in the end, not just use some cool new React 18 thing because you saw that on Twitter that it's cool. So think about it. Yeah, there was this stages talk about server components. There's me talking about Concurrent React. I'd like to invite you to some other amazing sessions on profiling or on doing transitions with React 18 and etc. Those will be complementary to a lot of things we just saw here, so I'm hyped about them as well. And probably the most important thing is I have stickers and swag, so if you're interested, just reach out. Let's talk about React, front-end performance, etc. And I got tons of these. Thank you all. That's all I had for today. Everything is going to be there.